Alright, this is Peter with CalcBook, and today we are going to be doing a custom T-shape in positive bending. So let's go ahead and open up CalcBook. We'll go into our steel module, we'll go into the member design, and we'll click on our Chapter F flexural design about the major axis. Once we're in the module, we can go ahead and click on Custom Shape. We can go in and click on Custom T, and we go ahead and enter in our dimensional properties for the shape. So we're going to have an 8-inch wide flange. It's going to be a 1/4 inch thick. We're going to do a 10-inch tall stem, and that's also going to be a 1/4 inch thick. It's going to be a built-up section, so we're just going to use 836 steel. And once we've done that, we can go ahead and click into our geometric properties, and it's already calculated all of the things that we're going to need in order to calculate the flexural capacity of this section. So our neutral axis, our moment of inertia, the plastic neutral axis, and anything else that we need for the flexural design. Once we have that information, we can go into our Chapter F tab, and we can go ahead and enter in our unbraced length. We also have the info button here, just to make sure you know what we're talking about here for the positive unbraced length. And we can go ahead and enter, and we're going to go ahead and do 15 feet for that, so 180 inches. And you see here we've got it in LRFD right, or sorry, in ASD right now. So we're going to go ahead and actually change that to LRFD. Once we have that, we can go to our demand. We are going to go ahead and put in a 25 kip-foot positive flexural demand on this. We've already done our analysis, so we have our moment demand for the section. And then we can go ahead and start to click into our design. So we can go ahead and click through here. We check our flange, right? So actually in this case our flange is non-compact. Check our stem, and our stem is also non-compact. So now we have our positive flexural strength, which is reminding us that this is when the stem is in tension. And if actually we were to change our loading, maybe we had a really big uplift, it would change, right? And now it says, okay, negative flexural strength, and the stem is in compression. And we would actually have to go back to our capacity and enter in the unbraced length for negative bending, right? And again, this would be a new image here showing a negative bending scenario. So we're going to go back here and remove that. We're doing positive bending in this video, and it'll switch back to stem and tension. So we can open that up, and it'll give us all of the failure modes that we're looking at for this design. So we have our plastic moment, our lateral torsional buckling, and then our flange local buckling, because we have a non-compact section. So we can expand each one of these, right? It takes us through each of the steps, because it's our graphs and our references, runs through the unbraced lengths for lateral torsional buckling, the capacities for each one, runs through the non-compact capacity, and then it gives us our design flexural strength, which in this case, it looks like we're slightly over capacity. So we could go back to our member properties, and we could increase maybe the thickness of the flange. Maybe we make this 3/8. And there we go. Now we're okay with our design. So that's it. That's our custom T-shape in positive bending using CalcBook.